Most scientists agree that nanotechnology is going to be our next big technological step forward. For NASA, nanotechnology will mean a giant leap outward.
We're looking at nanotechnology as ways that we can develop new materials, new sensors, things that will give us a tremendous jump in return on our science missions.
What is nanotechnology?
Nanotechnology is about creation of useful or functional materials, structures, devices in the nanometer length scale, thousands of times smaller than the average human hair.
By controlling and fabricating devices with perfect atomic structures, you get things like incredible strength and incredible electrical conductivity, or incredible strength and a super heat conductor, or maybe it's an optical conductor and it's a really good thermal conductor. These things are not usually mutually compatible, but on the nanoscale they are.
A basic nanotechnology structure is the carbon nanotube.
It's a graphite sheet, one atomic layer thick of carbon, wrapped on itself into a tube. It's extraordinarily long and thin, but very, very strong.
Researchers at NASA's Goddard Space Flight Center have developed an innovative method for manufacturing carbon nanotubes, which typically are made using a metal catalyst.
After they are made, you need to boil them in acid for 48 hours to clean them, get rid of your catalyst, and that increases their cost. In our case, we don't need the metal catalyst. You have an anode and a cathode. The anode is made out of a carbon rod. The cathode is made out of graphite. You're putting the rod really close to the surface of the cathode. You apply a current and it starts burning up the anode. And that's soot that deposits on the cathode. That's where the carbon nanotubes are.
This new method might have major implications for the future of nanotechnology.
We're getting higher yields. We avoid damage of the nanotubes. The cost is much lower. Real clean single-wall carbon nanotubes, they may cost you $500 a gram, and we can make them for approximately $10 a gram.
NASA is also looking at using carbon nanotubes to make novel materials with ideal properties.
We expect that the electrical conductivity will be better than copper. We expect the thermal properties to be as good as diamond. And we expect the mechanical properties to be as good as steel. Now, the great thing is that this nanocomposite material will be very light.
These unique properties provided by carbon nanotubes are widely applicable to NASA space work.
We are looking at carbon nanotubes for a number of applications like chemical sensors, biosensors, making future electronic devices and circuits and architectures. We are also looking at carbon nanotubes for advanced life support.
Collaboration is key to achieving NASA's goals.
I think collaboration is critical because a lot of people have some very creative ideas. Different people have different resources also. Nobody's got enough to do everything. We need to gel our resources and find out the best pieces and move those pieces forward.
Some of this collaboration is taking place within NASA.
NASA's newest focus on technology transfer is to find uses of technology development within the agency. We've been working with some of the other NASA centers, such as the Ames Research Center.
We have a very wide portfolio of activities in nanotechnology.
The nanotechnology work at NASA Ames composed of both experimental and computational work. We are having about 60 scientists coming from different backgrounds. We all working together try to solve the challenges for nanoscience and nanotechnology.
The research centers give us all the pieces of the puzzle that we get to put together as a flight center. And we take those pieces and we're able to put them together into a picture that is of interest and value to the scientists we support.
It is important for us to work with mission centers like Goddard, because they can take whatever we do and then they can actually convert them into a deployable technology. This can only happen with a partnership between a research center and a mission center.
NASA is also teaming up with the private, academic, and government sectors.
We're looking to see who else is out there developing nanotechnologies that we could partner with and perhaps spin that opportunity back into the NASA mission.
Our missions in general are characterized by their complexity. It's generally not possible for getting everything needed for that mission within the NASA centers.
We're working with the Johns Hopkins University's Applied Physics Lab, and then there's also an Army Research Lab, which are also very physically close to us, and that facilitates the ability to share equipment and to share research.
By broadening our scopes, we get access to top graduate students, faculty at universities. We get exposed to a lot of the issues within the commercial sector, a lot of startup companies.
And NASA is part of the Nanotech Alliance.
The Nanotechnology Alliance is a partnership of nonprofit organizations in the greater Washington area, federal laboratories, academic institutions, and some private nonprofit organizations as well. The charter is to facilitate resource exchange in the areas of nanotechnology application development.
Collaboration not only advances basic research by combining resources, but it also greatly contributes to technology transfer.
Technology transfer is very important to NASA. Nanotechnology is something we feel very strongly about.
So we're quite eager to explore partnerships and have folks come to us to work with our people. You can come in and work in our laboratories, and we'll work out arrangements so that we can have a technology and partnerships that work in the best interests of everyone.
And the potential for nanotechnology inside and outside NASA is enormous, from computers and electronics to healthcare.
Anything we do for NASA mission needs always has a benefit to the society. And nano is not going to be any different.
Nanotechnology is everywhere and everything. It is physics, it is chemistry, it is mathematics, it is engineering. So Jeanette's work has application in localized cancer treatment. We can now make a dramatically enhanced magnetic resonance imager, MRI. Or imagine that your car is now consuming 1/10 of the gasoline because 1/10 is heavy, but it is 4 or 5 times as strong, or has features that you never thought were possible, like reshaping itself, expanding for soccer practice, contracting for a fast trip down the coast. I mean, this is of ubiquitous importance.
But these advances can only be achieved by working together.
We're looking forward to working in partnership, to sharing our technology, transferring it out, and then having it transferred in, so that we can serve the American public well.